Welcome all of you. Welcome both of you to the physics class. In the physics class today, we'll be doing about units and dimensions, right? So we'll see what are units and dimensions, what are units and measurements, what are the different measurements, why we need to measure in physics. First of all, starting with what is physics, what are the different things that we are going to study. So Vedika, can you tell what we are going to study in physics?
Units and dimensions.
Units and dimensions, very good. But see, there is a lot of gap between your grade 10 and grade 11 physics. In grade 10, you just need to have the formula, apply it, and you will be able to get that. You have to be clear with your concepts. Whatever concepts are there, whatever points are there, you have to get through those concepts, and then you will be able to get it. It's not tough. Like you can forget about the calculation part. The calculation parts are a very little bit, but the understanding part is too much. You have to understand each and every point to be clear. Okay. So may I request all of you to turn on your cameras? Your cameras, if your cameras are on, it's easy to see what you people are doing. Okay, during the class, if anyone is having any doubt, if anyone is not being able to speak up, so please intimate it. You can use the chat section here. If you are facing any problem, you can message through the group. Okay. So basically what we study in physics, that we study about the nature and natural phenomena. So that is what we study in physics, nature and natural phenomena. So can you think what are the things that we need to study when we are studying the nature? Yes, we study here nature and natural phenomena. So in the natural phenomena, what are the different things we study and how can we study all the things? Please turn on your cameras. All of you turn on your cameras. I hope the screen is visible to everyone.
Yes, sir.
Okay. See, the very first chapter in your physics is units and measurements. So here we are going to study how we are going to measure the things and why we need to measure the things. So what are the things that we measure? Is everything measurable? Can we measure anything? Come on, everyone, be responsive in your classes. Can we measure anything?
Like not everything.
Okay, can I measure your feelings?
No,
No. Can I measure your intelligence?
no.
No. So obviously there are many things which we cannot measure and there are a number of things which we can measure. So first of all, we define the physical quantities. What the physical quantities, these are the quantities, or you can say the quantities which are measurable. You can say the measurable quantities are called physical quantities. So we'll see what are the measurable quantities and what are measurable quantities are called physical quantities. So can you give me the names of any measurable quantity?
Distance.
Hmm?
The distance.
Distance and distance and
Speed, mass.
speed, mass. Very good. So see, these are the physical quantities which generally describe an object, its position, its properties, the position, properties, various things of an object, they are described. Suppose you are given this rod. So what are the things that you can measure for it?
Length.
Okay, we can measure its length. Fine. And
Mass.
Width.
we can measure its mass. Any other thing?
Its volume.
Volume. Very good. Anything? Any other thing?
Area of cross section.
Area of cross section. Very good. Any other quantity? Any other thing that we
Its
can measure
density.
for this rod? Yes,
Its density.
we can measure its density. Very good. Okay, so these are the different things that we can measure about this rod, and all these quantities, they give us some idea about this rod. For example, the length give us an idea that how long it is, the mass give us that what will be the content of matter in it, volumes gives us an idea that how much space will it occupy. So in the similar way, all these are the physical quantities. These are the different things which we can measure about this rod, and all these are the physical quantities, right? So you can also understand what that physical quantities are, the quantities which are used to describe some objects, not only objects, maybe their properties. To describe the properties, we use some quantities which are called as physical quantities, right? So there are certain quantities which are used to describe. For example, I can say that someone is very beautiful, but there is no measurement of that. Okay, so
Yes.
that beautiful is not a physical quantity, it is just a quantity. Understood?
Feature.
Okay, so in physics we study about the physical quantities, and these physical quantities, they give us an idea that how the physical quantities, they give us about the depth of that unit. What are the things that we can think of, what its different properties we can study out of. Now we have a number of physical quantities, like you described here: length, mass, volume, area of cross section, density. We have a number of physical quantities. Now, out of all these physical quantities, our SI system of units. So SI system of units has introduced seven fundamental quantities. Okay. The seven fundamental quantities of the SI system. So can anyone name the seven fundamental quantities?
Length.
Length and
Mass.
mass.
Volume.
No, not volume. Volume is not a fundamental quantity. So what are fundamental physical quantities first of all?
Charge.
Charge. No. See, fundamental physical quantities are the quantities which do not require any other quantity for their description. They do not require any other quantity for their description. For example, length, mass, time, temperature. So length, mass, time, temperature, amount of substance, luminous current, and luminous intensity. So see, these are the seven fundamental quantities as described by SI system of units. Now, these are the quantities that we cannot express them in terms of any other quantity. We cannot measure length, we cannot express length in terms of any other physical quantity. However, if you want volume, so we can express volume in some other terms. We can express volume in terms of length. We can express density in terms of mass and volume, right? But these are the quantities which cannot be expressed in any other terms of it. So therefore, these quantities, they require some standards. They require their definitions. Okay. So, how do you think should we define the length? What should be the unit of length? Since you want to measure the length, so you will be using an appropriate unit for measurement of the length. What are the different units that we use for the measurement of length?
Meter.
Yes. Different units that are used for the measurement of length. See, we have different units. For example, length can be measured in meter. It's measured in centimeter. It's also measured in foot. Okay. Some of the local people, they may also use hand span. So these are the different ways or different methods of measuring the fundamental quantities. Okay. So Dhatri mic not working, Vedika camera computer. Okay. And Jaswant, what about you? What about your mic and camera?
So yes, sir, working.
Okay, so please turn it on. Jaswant, Pritam, keep your mic and camera on. So length will be measured in SI. Length can be measured in meter. It can be measured in centimeter. It can be measured in foot. So all these meter, centimeter, foot, they are units. They are the units of measurement. Okay. Now, out of these units of measurement, the SI system gives us meter. SI system defines meter to be the SI unit of meter, SI unit of length. So whenever whenever we have to measure length, length will always be measured in meter. The SI system also defines mass to be kilogram. In the SI system, mass will be measured in kilogram. Apart from kilogram, there are other units. There are units gram. Other units are also there, pound. But in SI system of units, we use kilogram. Can anyone guess the SI unit of time?
Second.
SI unit of time?
Seconds.
Seconds. SI unit of time is second. What is the SI unit of temperature?
Kelvin.
Yes.
Kelvin. The SI unit of temperature is Kelvin. What is the SI unit of amount of substance?
Mole.
Mole. Very good. And SI unit of current is ampere. The SI unit of luminous intensity is candela. Now, see, to measure the length, we use meter as the SI system of units. So, of course, we should also define that what should be 1 meter. Yes, what should be 1 meter? To what distance shall we call as the 1 meter?
100 centimeters.
How much?
100 centimeters.
100 centimeter. But how we will define then 1 centimeter? Yes, how we will define 1 centimeter then? See, of course, we need to know. Our problem is that we want to set up, we want to know that how much distance should we call as 1 meter. So, shall I take this much as 1 meter, this much as 1 meter? So, what should be the distance that I should call as 1 meter?
So it's a fixed standard, like for everything it's only one.
It's a standard. So, how do we choose that standard? Of course, you are very close. So, how do we choose that standard? How can we say that yes, this will be 1 meter? How can we make that standard? See, the way we define 1 meter is defined in terms of scientific community. It is defined in terms of the speed of light. So the distance, what distance we will call as 1 meter? The distance 1 meter would be, it would be the distance traveled by light. Since the speed of light is a constant, so the distance traveled by light in 1 over eighth, this much of a second. So the quantity which you see in the denominator, 299,458,798, this is the speed of light. So the distance traveled by light in this much of a second we will call this distance to be 1 meter in vacuum. So see, earlier the distance was defined in various other terms. For example, the distance was defined using a meter scale. You can define this distance in terms of meter scale. Suppose it can be that all the scientists agree to take a meter scale and then say that, okay, this will be 1 meter, right? But that was not defined as to be 1 meter. It was found inappropriate. For example, if you choose a meter scale to be of 1 meter and declare it to be 1 meter. So can you guess what are the problems that we can face? What are the problems that we can face? Yes, will there be any problem if I just use a meter scale and the scientific community says that yes, this 1 meter is accepted as 1 meter? Yes, will there be any problem?
Yeah,
Okay, what problem will be there?
it won't be appropriate.
Yeah,
It won't be appropriate.
it won't be appropriate. Why it won't be appropriate?
The value.
Why we cannot accept a meter stick to be of 1 meter? Any reasons? Just want any reasons? Okay, have you heard that metals expand on heating?
Yeah,
Solids expand on heating and contract on cooling, right? So, if you take a meter scale, suppose if you choose a meter scale, so you use that meter scale in Antarctica, you use that meter scale in a Sahara desert. So, will there be any differences in the measurement of the length?
yeah.
Yeah, because
Solids
in the
expand.
deserts, yeah,
Solids expand.
yeah, it will expand. So, it will not give you an accurate measure, right? So we cannot declare that meter stick to be a standard. The meter stick cannot be declared as a standard because it is not fixed. It will keep on changing. Okay. So the distance traveled by light in this much of a second in vacuum. So the speed of light is constant in vacuum, and in this much of second, whatever distance the light travels, to that distance we will call as 1 meter. Right? So this is the distance traveled by light uh, in you can say 1 over 3 into 10 to the power 8 of a second. Right? So this much distance will be 1 meter. So in the similar way, the SI system, it defines the other units also. Like the distance, the amount mass is measured in kilogram, and this in the same way, SI system defines 1 kilogram. So how can you say 1 kilogram? 1 kilogram, it is defined as a prototype of mass. So a prototype has been made of platinum and iridium. So a platinum and iridium prototype has been kept, which we call as a 1 kilogram. So there is a platinum and iridium prototype kept in International Bureau of Sciences, France, that we call as 1 kilogram. Right? So how we define 1 kilogram? 1 kilogram is the mass of a prototype kept at International Bureau at Paris, France. So it is made up of, this is made up of platinum and iridium. So since platinum and iridium over there, the mass decay is considered to be very less. It's non-reactant. So therefore the alloy, it is made up of an alloy of platinum and iridium. It is kept at a constant temperature and pressure. So everything of that room is maintained at
What
which
is the
we
alloy
keep.
name?
Yeah.
What is the alloy?
Yes, you are audible, Pritham.
Like, what is the alloy name?
What is?
The alloy name which you mentioned.
Platinum and iridium. It's made up of platinum and iridium.
Like, what is the thing made?
No, there is no specific name. It's just platinum and iridium alloy.
Okay, platinum.
Okay. So it's platinum and iridium alloy kept at International Bureau of Standards, Weights and Measures, Paris, France. Copies of it were generated and those copies have been distributed worldwide.
Hmm.
Okay. So those that we take as a 1 kilogram. Now the mass does not, the mass can change over time. Mass can also change over time if there is radioactivity or any other thing, then mass can change. But this alloy, it shows least radioactivity and it is kept at a standard. It is kept at a standard temperature and pressure so that there is no change. It is closed in a container. Okay. Then how we define 1 second? We have to define a moment of 1 second. So how we define 1 second? See, in the similar way, just we define length, we define mass. So the same way, your time is also defined. And for time, we use an atomic clock. That atomic clock we'll call as the cesium clock. It's made up of cesium-133 atom. Okay. So what happens to cesium-133 atom? In cesium-133 atom, we count the number of vibrations. Okay, so that is the best clock that we use, and we count over there the number of vibrations. Okay, so whatever is the number of vibrations, see, we define that as the number of vibrations per second. How many? There is a number of vibrations. Let's see, 1 second. So you have defining of 1 second. You have some number of vibrations which are counted over counted over between two hyperfine levels of cesium. See, 1 second is the amount of time it takes for 9192631770 cycles of radiation to pass between two levels of cesium-133 atom. Okay, so basically, as of now, I don't think that you understand it in anymore. You will be finding it very difficult to understand, but you do not remember. You should not remember these words. Yeah, you are not supposed to remember these numbers and all. Yes, you should understand that how we are reaching at a standard, why we are choosing a standard, and what this standard means. So 1 second, it actually means to 9192631770 transitions of cesium-133 atom. If these many cycles of radiations, that means if the cesium-133 atom radiates this much of radiations, so you count these radiations, if the number of radiations is 9192631770, then that interval of time will be called as 1 second. Okay, so I hope you have understood this definition of 1 second. So this is the most appropriate clock which is being used. Got it? So cesium, this is the definition of 1 second. So we can define 1 second as the number of transitions of 9192, 760 and 458. I think that's the number. Yeah, 9192631770 cycles of radiation of cesium-133 atom. So if this many radiations we are going to count from cesium, we call it as 1 second. So in the similar way, all the standards have been kept. You cannot use any substandard. For example, you cannot make a meter stick and say that this is 1 meter. You cannot choose an iron object and say that this is 1 kilogram. There is a standardization to everything. In the similar way, we have defined temperature, Kelvin. So what we call as 1 Kelvin. Okay. So for defining 1 Kelvin, we have something as triple point of water. Beta, see, I expect all of you to keep your cameras on. This helps me in keeping on giving out a proper classes. Okay. You can use any backdrop if you prefer. So, are you getting these things or not? Are you able to get all the things?
Yes, sir.
Yes.
Yeah.
Okay. So all the things should be understood. If you are not able to get any points, do inform. The best way is that we communicate. If you do not know, do not get, these are the basic points, basic definitions of a system of units. So see how we define 1 Kelvin. 1 Kelvin is defined as the 1 over 273.16 of the triple point of water. So, what do you mean by triple point of water? One Kelvin is defined as 1 over 273.16 of the triple point of water. So, let's see what is triple point of water. By triple point of water, as you know, that we can change from water to ice to water. So, at what temperature does this transition take place from ice to water? Yes, at what temperature does ice change from ice to water?
Sir, above 0.
Above 0.
Yes.
So, okay, let's say above 0. I'm writing here above 0. Okay. At what temperature does water change to ice?
100 degrees Celsius.
Water to ice
At 0.
at 0. Right? You say
Hmm.
at 0?
Yes.
See, this is not the condition. The condition is actually here. You do not have only temperature as the function. You have here two other things which are playing role. You have here two things. You have here temperature, and apart from temperature, you have atmospheric pressure. So pressure is another factor which affects melting and freezing. Right? So 0 degree Celsius is the equilibrium position. At 0 degree Celsius, it can exist at ice, as ice also, it can exist at water also. So a combination of temperature and pressure, a condition of temperature and pressure at which water will exist in all the three forms. Right? So there will be a condition of temperature and pressure. For example, the pressure given over there at time is 0.01 bar. Okay. So at this pressure and a temperature, so that water will exist in all the three forms. So that is a single temperature. So 1 over 273.16 of triple point of water. Triple point means the temperature at which water will coexist in all the three forms. So you can very well guess that what is the level of standardization. Okay, we have standardized everything so that there is not even a minor chances of the units being disrupted. Okay, so 1 Kelvin is 1 over 273.16 of triple point of water. So in the similar way, we have defined all the other fundamental quantities. All the other fundamental quantities like we see here length, mass, time, temperature. In the same way, amount of substance is mole. So in the same way, it has also been defined. Current has also been defined as 1 ampere. So in similar way, so what current we will call as 1 ampere of current. What amount of light will be there so that we will call that light to be 1 candela. So these all are SI system of units, and here we see that all the units, everything, they are standardized. All the units have been made into a standard, right? So these was today's class. We had discussed about the fundamental units or fundamental physical quantities. They are also called as basic physical quantities. Funda means basic. Now, all the other physical quantities, they can be written in terms of these fundamental quantities. Okay. Any other physical quantity. For example, if we try to write down volume. Okay. So suppose we write down volume over here. We find out area. We find out volume. So volume is generally written as L times B times H. So length, breadth and height. So breadth is also a type of length. Height is also a type of length. So all these can be measured in dimensions of length. Right? So volume will have the dimensions of L cube, length multiply length multiply length. In the similar way, area can be expressed in terms of length only. Area means length multiply breadth, whereas breadth is also a type of length. Okay, so we will call these quantities which can be made by using other fundamental quantities. These physical quantities, they are called as derived units. So the quantities which have been made from, which can be obtained by other physical quantities, they are called as derived physical quantities. The quantities which cannot be defined in any other terms, they are the fundamental quantities. So these are derived physical quantities.
Definition again.
For derived physical quantities,
Yeah.
the quantities which can be expressed in terms of fundamental quantities. Okay, anyone who has not understood anything? See, we will start from the very basic, raise the standards slowly as we go deeper into the chapter. Okay. So what are the anyone having any doubt?
No.
No?
No, sir.
See, your doubts will be cleared here only. And I want everyone to be speaking, to be active during the class. It's not a passive class. You have to be active during the class. Okay. Suppose if there is a class of 1,000 students, then you can be passive. But here you have to be active. And here I'm writing the definition for the derived physical quantities, the quantity which can be expressed. The quantity which can be expressed in terms of fundamental quantities. Okay. So the quantity which can be expressed in terms of fundamental quantities are called derived quantities. So can anyone give me any other example of derived quantity? Yes, anyone can give any other?
Speed.
Speed, very good. Speed is a derived physical quantity. Any other? What about force? Is force a derived physical quantity or not?
Yes.
Yes. Force is a derived physical quantity, right? So now you have got the definition. What are fundamental quantities? What are derived physical quantities? Just one more thing adding up here. Here we have discussed mainly about the SI system of units. So SI system of units, they are the international system of units which have been accepted for measuring the physical quantities. However, some people may use other units like FPS system. You have a CGS system. So can you guess what does FPS system stands for?
Foot, pound, and second.
Yeah, foot, pound, and second. So it will be FPS means foot, pound, second. CGS means centimeter, gram, and second. You have MKS system, meter, kilogram, second. Okay. So these are the different system of measurements. But here, throughout our studies, we will be referring through SI system of units. Okay. So bye everyone. Just if you had any doubts, so please do inform me right now. Just one.
Yes, sir.
Did you understood everything?
Yes, sir.
Okay, see. So today we just started with the basic of the units, how we measure the physical quantities, right? Okay, bye everyone. Good night and see you tomorrow again at the same time.